Hello, everybody. Today, we are going to be making a pretty pivotal part of your final project. This is going to be a highly referenced page. So, it is going to be really important today that you are listening and following along to understand, not just to copy down and attempt to get your points. So, what we are doing today is identifying what traits or properties make your element and your make your toxin and your biological essential look similar. So task 5, you'll notice it has two papers that look exactly the same. On the front, I'm going to walk through the task for lead and calcium, and then on the back, you'll do the exact same thing, looking up the exact same facts for your selected elemental pairs. Some of it's easy. We've been doing it for a while. Some of it is going to be a little bit newer to you. So, first thing we're going to do, determine the basic structural facts for toxin. The class toxin we are investigating is lead, which is PB. We should all know that. So, we need to copy the card as it's given to you on your periodic table. So lead is element 82. Its atomic mass is 207.2. We are going to round that to a whole number. So we're going to round that to 207. Now, we need to identify these facts about this element. The first fact that we want to identify is the category. So for category, we have already taken notes over this on your introduction page. Remember, the categories are going to be metal, non-metal, or metalloid. Those are going to be our three options. And you can figure it out based on the coloring of the periodic table that you've done. Remember, mine is not colored in. Yours is, though, one you should have in front of you. Anything to the left of the staircase is a metal. Lead does fall left of the staircase, so it is going to be classified as a metal. The color coding you've done has also already identified the family name, which is going to be one of these up here. So every element can fall into one of these categories. Lead we have already colored in. It is a inner transition metal. Valence electrons. Another thing, we can get this straight from our table. Lead is in column number 4, which means it is going to have 4 valence electrons. Now, lead is a little bit tricky, and this is why we're doing lead as a class and lead was not up for grabs as an individual project. Common ion. Generally, you can get this from the table. However, you may need to Google it. So far, everything we can get directly from the table. Lead, however, is a bit of a rule breaker. So you might notice on my table that lead is starred, as is the element right above it, 10. Lead is in the +-4 column. However, it is not actually going to form a +2 charge generally. If you Google common ions for lead, What you will learn is lead actually forms, it's still positive, but it's a positive 2 ion charge instead of a positive 4 ion charge. So I'm a little bit limited. I can't show you that Google screen since I'm on video on paper here, but for this one, you will need to look it up and reference your table. So you'll do both. Ionic radius is another one that you're going to need to look up or Google. I give you guys a hyperlink in here, but you're watching a video, you've already got the planner up. If you open the planner and under today's date, there's a link there that says ionic radius table. You open that up and it will tell you the ionic radius of every single element. So you scroll through that table. I'm going to scroll through it and find lead. And the ionic radius for lead is 1.19 angstroms. But please use the link provided in your planner. To identify this information. Okay, and then the last 4, we kind of started on hard. So good news, we got the simple ones left. Protons, neutrons, electrons, mass. Some of these, I can get them right from my table. Mass is 207. AMUs. Protons are 82. We know how to, and we've been calculating neutrons for a while. So that's going to be my mass, which is 207, minus my protons, which is 82. Let's see, 7, so that's going to be 5. I had to borrow 8, 9, 10, 11, 3. So 135. Yes, so I would have 135 neutrons. And then lastly, electrons, assuming a neutral atom, are always going to be the same as protons. And we are going to assume a neutral atom. Okay, so that's lead. We're going to do calcium next. This one, going to go a bit faster. Same process, same lookup locations. So element card, we're going to get that straight from the periodic table. Whoop, off screen. Element 20, mass is 40. The first 4 things we are going to get directly from the periodic table. The common ion here is going to fall and be nice, but again, sometimes you may need to Google that one. Always good to have a secondary source. So category, calcium is to the left of our metalloid staircase, which means calcium is going to be a metal. On your color coding, you guys have already identified calcium as a part of column 2, which we have named the alkaline earth metal family. Again, we're just looking at the color coding that you have already done. Valence electrons, we've been talking about that for a while. That's again via the column. Calcium is in column 2. It has 2 valence electrons, and while I'm here, I'm going to check. It also forms an ion with a +2 charge. And then To verify when you Google it, you would find calcium is exclusively going to form a +2 ion. So that one is going to be there and correct. Ionic radius, remember, we have got to look that up in the table provided. So you'd open up the hyperlink from your planner and let me find calcium. Calcium has a radius of 0.99 angstroms. Okay. And then for protons, neutrons, electrons, mass of 40, protons of 20. We got much easier math this time. Neutrons is going to be 40 minus 20 because it's going to be mass minus protons. And then assuming a neutral atom, protons and electrons are always going to be equal. Okay, so we've got it filled out, but we are not quite done. The last step that we want to do is highlight similarities. I think it just did not fit in your margins. So similarities are going to be either traits that are the exact same or very, very close to the same. So for example, for the category, those are discrete categories. Lead is a metal, calcium is also a metal. So I'm going to highlight that for both. Metal, metal. Let me see if I can zoom out. Okay. Family, lead is an intertransition metal, calcium is an alkaline earth metal. That is not the same. So not going to highlight that. Valence electrons, lead has 4, calcium has 2. Not the same, not going to highlight that. Common ion, lead is +2, calcium is also +2. So I am going to go ahead and highlight that. Now, ionic radius is one of those that is not going to be dead on. So we consider anything within 0.3 to be similar. I'll make a note of that down here. So radius plus or minus 0.3 is similar. So here, calcium functionally has a radius of 1. Lead has a radius of 1.2. Those are within 0.3. So those are similar. Protons, not going to match because if they match, they would be the same element. Neutrons not matching, electrons and mass not matching. So here we've got 3 traits that make lead and calcium biological mimics. And remember, these are notes we took way back when we talked about what is a biological mimic. So let's see how many we hit. Lead and calcium, are they the same category? Yep. Are they the same ion type? Yes, they're both positive. More specifically, they're the exact same positive. They're both +2. Same family? Nope. Valence electrons? Nope. Size radius? Yes. So we're not hitting all of the traits, but we have hit enough that the body identifies these elements as similar and it treats them as such. So your task now is to do the exact same thing for your element. So you're going to fill out the same table. You're going to look up information in the same way, except you're going to do your toxin compared to your necessity. And do not forget to go through at the end and do the highlighting. Okay, that's going to be essential for when you're making your project. because this is so fast for me to check. How many similarities do I have? 3. What are they? Category, ion, radius slash size. So go ahead and complete the next page on your own for your selected toxin and necessity.